All right, now we're going to look at the next two examples. We have graphs here, and then over on example 7 and 8, we have coordinates. These are the last two types of things we need to figure out what type of function is being shown, so that way we have a plan, or we can start to have a plan for how we want to solve. So example 5 and 6 are both graphs. You need to be able to tell what type of function it is based on what the graph looks like. So in example 5, we have a graph that starts off really flat here, and then it goes up pretty fast. Or I drew one. It starts off flat, and then it goes down pretty fast. Okay, it also could go up and then get flat, or it could go down and then get flat. But either way, part of it's flat, and then part of it's really steep. If you see these types of functions, they are exponential. Right? So starts flat, goes up steep. Example 6 here. We have a graph that is a U shape. Okay, this is called a parabola. If you remember back from chapter 8 and 9, it is a quadratic function. Your other two choices that are not given an example, if you have a straight line, either up or down, it is linear. If you have a V shape, so it's two straight lines that connect in a perfect at your vertex, this is absolute value. Okay, and your other option, if you happen to see where you got like open circles with lines or closed circles with lines, this would be your piecewise. Okay, so based on what the graph looks like, you need to know what type of function it is. Our other two things here are dealing with coordinates. Now, for coordinates, you have two options of how you want to solve it. You could either graph it, or you could put them in a table. It is your choice. Okay, you're not always necessarily going to have graph paper. Table might be your better option, but you will have Desmos, so graphing might be your better option. Up to you. So for example 7, we're going to graph these points. We have -1, -2, 0, -3, 1, -2, 2, 1, and 3, 6. So if I connect those points, okay, it might be kind of hard to see, but if you look, when I connect those dots, it's starting to look like this graph down here. We went down and then back up. So we went down and then back up. So this is the beginnings of a quadratic function. Our other way we could do it is a table. So I'm going to put the numbers in. Our first number is x, our second number is y. -10 goes with 15, -9 goes with 17, -8 goes with 19, -7 goes with 21, -6 goes with 23. Okay, now if you remember from yesterday, we're going to figure out how the y value changes to go from one to the next. I'm going to check multiplication first to rule out exponential. So I cannot multiply by anything to go from one to the next. So now I'm going to check adding and subtracting. So I see here I would have to add 2. 17 to 19, I'd have to add 2. 19 to 21, add 2. 21 to 23, add 2. It's the same every time in this first difference here. Okay, from yesterday, if the first difference is the same, it is a linear function. So all you would need to do here, graph the coordinates or plot them in a table, figure out which is changing, how the pattern's going, and that will help you to identify your function.